Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we are going to be looking at two-dimensional coordinates. After this lesson, you will know what a coordinate system is and how we can use them. You will know what a coordinate point is. You will know how to draw a coordinate system using an x-axis and a y-axis. And finally, you will learn how to plot coordinates on this xy coordinate diagram. So, let's get started.
Ooh la la!
So here we have a map of the world. I'm currently here in Scotland filming this video, and down here somewhere is the South Pole where our little penguin friends are hanging about. And sometimes, well, a lot of times when we travel or you have boats, airplanes, when they go travelling, it's good to define destinations on a map or using some form of coordinate system. So for example, I might want to say I'm here using some form of coordinate system. You might want to say you're here, and someone else might want to say they're up there. And the way this is normally done on a 3D setting or a globe such as our Earth is by using things called latitude and longitude. And defining points on a 3D surface such as the Earth can be quite complicated, but what we can do, we can sort of simplify it down and imagine that our space around us is a 2D sheet of paper or on a flat surface and define points on that. And we can do this by using what is called a 2D coordinate system, and this just gives us a representation of the world in 2 dimensions. So if we're working on a flat piece of paper, or if you do believe the Earth is flat, I'm not going to tell you what you should and shouldn't believe, but we can use a 2D coordinate system to represent a flat world. And the 2 dimensions part of this means that we can move in this direction, so vertically up and down, and also horizontally from left to right. And using this form of coordinate system, we can define points which are known as coordinates if we set a scale using both of these lines here. So all of these points we see on this sort of diagram are called coordinates, and these 2 lines which define the scale of the system are called the axes. And in particular, we call this one running left to right the x-axis, and this one going up and down the y-axis. And the way that we can use the x-axis and the y-axis to define the position of coordinates is by having a scale along each axis. So let's give an example of how we can draw a scale. In any coordinate system that we draw, the point in which the x-axis and the y-axis intercepts is called the origin. So this point here right in the middle is called the origin. And this is the point where, when we define each of these points, or the distance it is away from the x-axis or the y-axis, we use this origin as reference. So it's the most important point that we can remember on this coordinate system, just the point in the middle between the x-axis and the y-axis. And because it's the point where both lines intersect, we also call this the zero reference point, which means that along the x-axis and the y-axis, this position is classed as 0. So that means that when we go to start drawing a scale along each of the axes, this is always going to be a 0 point. So if we have here steps of 1, 2, 3, 4, if we go back one, then this point is going to be 0 on the x-axis. And for the y-axis, that's also the case. So working back from 3 to 1, this point is also 0. So for some rules, when we draw the scale on the x and y-axis, one thing that's always true for the x-axis is, from the right-hand side of the origin, this is the positive side, and to the left-hand side is the negative side. So that means if we're drawing a scale on the x-axis and we work our way back from 4, 3, 2, 1, 0, that means after this point to the left, it's negative numbers. So it goes on to -1, -2, -3, and -4. So for the x-axis, to the right of the origin is positive and gets increasingly bigger, and to the left-hand side is negative and we get increasingly smaller or more negative as we go further to the left. And for the y-axis, if we're above the origin, then we are positive. So if we keep going up, we have 1, 2, 3, and we go up and up and up, we keep getting more positive or bigger. But as we work our way back down to the origin, we get to 0. Below the origin, we have negative numbers along the y-axis, just like we have here. So the numbers get more negative as we go down the y-axis. So just to recap that, we have up and right are positive, and left and down are negative for both the x-axis and the y-axis. So now we know how to draw a coordinate system like this in the correct way with the x and y-axis. We now have to draw coordinate points on the diagram, or know how to draw coordinate points on the diagram. And because we have two axes, the x-axis and the y-axis, that means that we need two numbers in order to represent a point, and one number relating to the x-axis and the distance it is along it, and the y-axis and the distance it is along that. So let's have a look at this point here. In order to represent this, we want to know the distance it comes along the x-axis and the distance it comes along the y-axis. And we can see here, using a little scale, we can see that it comes along the x-axis. If we start at the origin, it comes along the x-axis at 2, and it also comes along the y-axis at 2 as well. And the way that we write this out is, we put the number that it comes along the x-axis, or the distance it is across, and the distance along the y-axis. So we could say that this point here is the coordinate 2, 2. So this is how we draw a coordinate point out. The first number represents the distance along the x-axis, so 2, and then the second one represents the y distance, 2 again. So to summarise that a little bit, when we want to plot points on an xy diagram such as this one, we want to first measure the x distance of the point, so along this axis, and then the y distance, so along the vertical axis going up and down. And then once we've done that, we can write out the coordinate in the form of x, y, so the x distance and then the y distance, so the x first and then the y. Sometimes in questions you might be given a diagram like this already, and all you have to do is draw points on it, but other times you might have to draw one of these yourself. And there isn't really much to it. Obviously all you need is an x-axis and a y-axis, so a line going horizontally and a line going vertically, but just make sure that you've got enough space on either side of the axis to draw any points that you might be given. So the scale that I've drawn here, for example, goes up until 7, and each of these little lines represents a distance of 1. So here we have 1, 2, 3, 4, 5, 6, 7, and then going the other way as well, the negative direction on the x-axis, we would have -1, -2, -3, and so on. And the same for the y-axis as well. So I'm saying this is 1, 2, 3, 4, and so on. And then the negative direction, -1, -2, -3, -4. So I don't want to label each one of these lines with the number because it will end up too crowded, but as long as you and the person that might be marking the problem that you're doing both know what the scale means. So for here, I have a maximum distance of like 7 and -7 on either side, and each of the little lines represents a distance of 1. Obviously, if we wanted to do a bigger problem with larger coordinates, then we would have to extend this or adjust the scale. So what we're going to do first, I'm going to list coordinates in their coordinate form, and that means that we need to plot it on this diagram. And then after that, I'm going to draw first points on the diagram, and then we have to write out the coordinates for them. So first, we're going to plot the coordinate 3, 2. So we already know that both of these numbers represent the distance along the x and y axis, and the first one we know represents the x distance, and this one represents the y distance. So beginning with the x number, if we want to plot 3, we know that the positive direction on the x-axis is to the right, so that means that we want to move along 3 places to the right. So that's 1, 2, 3, so the point is going to be somewhere along this line here, and we know the y distance is 2, positive 2 that is, so that means that we're going to be moving up 2 places. So putting that together, we move along 3 along the x-axis, positive, and then we move up 2 on the y. So this right here is our point 3, 2. And again, we can see that we've moved 1, 2, 3 along the x, and then 1, 2 up the y, and that gets us at this point. Now what about the point 4, 1? So what that means is we're moving 4 places along the x-axis to the right, and then 1 place up the y-axis. So starting at the origin, we move 4 places to the right, 1, 2, 3, and 4, and then we move 1 up, so that gets us the point right here, 4, 1. So just a quick reminder, along the x-axis, to the right is positive and to the left is negative, and for the y-axis, up is positive and down is negative. So what if you're asked to plot the point 4 minus 3. Well, the first number is the x-axis, so that means x is still positive. That's positive 4. But that means now the y number is negative. And if it's negative in the y, that means that we're going to be going down 3 places. So that means that in the x direction, we're going to go 1, 2, 3 and 4. And then the y direction, we're going to be going down 3 or negative 3. So that's 1, 2, 3, and that's the point there, 4 minus 3. So let's look at one example here, one final one for this, and the point is minus 5, 2. So the first one, minus 5, is in the x direction, and now if it's negative in the x direction, that means that we're going to be going left. And the second number is the y direction, and if it's positive 2, that means that we're going to be going up in the y direction. So beginning with the x, we're moving 5 places negative, so that's to the left. So 1, 2, 3, 4, 5, and then we're moving 2 places in the positive y direction, so that's up 1 and 2, and that would be the point there, minus 5, 2. So that was 4 examples of how we can plot each of these coordinate points, but now we're going to reverse the task. I'm going to draw points first, and then we have to write out the coordinates for the points. So here we have 5 points drawn on the coordinate system, and it's our job to fill in what the points are. So what you could do for a little bit of practice is pause the video right now and see what answers you get for each one of these, and see if it gets the same answers as me. So let's begin with the blue one first. To get this first number, it's the distance across the x-axis. So we're going to begin here with the blue, and we know that it's across 1, 2, 3, 4, and that was in the positive x direction. And now we're going to be going up, so that's also going to be positive in the y, and that'll be 1, 2, 3, 4, 5, 6 across there. So that means that the blue point here has the coordinates 4, 6. So next we're going to do the red point, and then again beginning with the x coordinate first, we can see that this time it's to the left hand side, so that means that the x is going to be negative. So how much negative? Well, let's see, 1, 2, 3, 4, 5, 6, 7 to the left, so that means that the x is going to be minus 7. And we can also see that this point is below the axis, so that means it's going to be negative in the y direction as well. So here we have 1, this is 2, so we can see the point lies in between 1 and 2, so halfway between 1 and 2, we can say that's 1.5. So that means that this red point here has the coordinates minus 7, minus 1.5. Now next up is the green point, and we can see that here the green point actually lies on the origin, and we know that for the origin it doesn't move in any direction at all, so we can say that the green point has the coordinates 0, 0, because that's always the coordinate point of a point located on the origin or the intersect between the x and y axis. So next up we have the purple point, and we can see that from the x direction it doesn't move at all, positive or negative, so that means that the x direction or the x distance is just 0. But then in the y direction we move down in the negative direction, so that means that we're moving down 1, 2, 3, 4, 5, 6 places in the negative direction, so that means that we have the coordinates 0, negative 6. And then finally for the yellow point, we're moving positive again in the x direction, so that means we're moving 1, 2, 3, 4, 5, 6 positive in the x, and then we're also moving down in the y, so that means we're moving negative in the y direction, so we're moving 1, 2, 3 down, so that means that we have the coordinate point of 6, negative 3. So let's recap this lesson on coordinate systems. So a 2D coordinate system is a way of representing points or coordinates in 2D space, so in other words on a flat piece of paper or an imaginary flat world. And the coordinate system consists of an x-axis which runs horizontally and a y-axis which runs vertically, and the point on which these axes intercept is called the origin. The way that we can write these points out is by writing the x distance and then the y distance from the origin. And we now know that for the x-axis, moving to the left of the origin is negative, and moving to the right is positive. And for the y-axis, moving up is positive, but moving down is negative. And then finally, if we want to plot something like this, we begin at the origin and we move in the direction of the x. So we begin by plotting the x and putting in the distance here. And then once we have the x, we can then discover what the y value is by moving either up or down to the coordinate. I hope this video has been helpful to you in your National 4 Maths learning, and if that's been the case, be sure to give the video a like and share it with your friends. And if you'd like more content like this, be sure to subscribe to our channel or head to our website at penguin-learning.com. As always, thanks a lot for watching, and I'll see you in the next video.